Hey everybody, thanks for coming to my talk. So today we're going to talk about from MLOps to MLOops, exposing the attack surface of machine learning platforms. So a few words about myself. My name is Shachar Menashe. Classically, I'm a binary reverse engineer. Nowadays, I mostly assign CVEs, CVSS scores, which is also fun. And I lead JFrog security research teams. So we do zero-day analysis, CVE analysis, and malware analysis. And today I'm going to present recent research that we did in our zero-day team, which included myself, Ori Olander, Natan Neorai, and Uriah Avnieli. All right, so what is this talk about? Why should you care about this talk? So when attackers infiltrate an organization's network, they hunt for high-value targets. These are targets that will allow them to spread into the entire organization. So an obvious example is a domain controller. If an attacker gets in your domain controller, then they can hijack the entire domain. Another example is IT orchestration framework. So if an attacker takes over that, they can publish packages to all of the machines in the organization and take over the entire organization. What I want to argue today and show you today that MLOps platforms are a new high-value target, and hijacking them leads to massive spread. Think SolarWinds, but for AI. Okay, so today we're going to have a bit of intro about MLOps platforms. We're going to break them down into distinct features and see how each feature individually can be attacked when this MLOps platform is deployed in an organizational framework. We're going to have a fun demo where we exploit one of the 0 days that we found as part of this research. And in the end, we're going to see how to avoid these attacks as well. OK, so a bit of intro about MLOps platforms. So this is the usual ML software supply chain. This is what you need to do in order to create a machine learning model. So first of all, you choose a machine learning algorithm. So these are well-known algorithms, for example, decision trees or SVM. Once you choose an algorithm, you feed a data set to that algorithm. So the data set is the data that we want our model to know about and be able to answer questions about. So this process of feeding the data set is called training the model. And this results in something that is called a pre-trained model. So this is an object that when we queried, and you can query, answer it questions like ChatGPT, and it will answer. And when the model is ready, when we have this pre-trained model, we need version control. So version control is usually happening in the model registry. This is what will allow us to save all the versions of the model. And in the end, when we want to deploy the model to production, we use a MLOps platform feature called model serving, or model as a service, and this will allow us to let clients query this model. So this whole supply chain can be done either manually by an ML developer or a data scientist, or we can use a machine learning pipeline, which we'll also see what that means, in order to automate all of this process. OK, so let's start with a machine learning pipeline. So MLOps platforms provide us the ability to construct and run a pipeline. So this is just a bunch of code, usually Python code, and it allows us to automate monitoring for data changes. So we have the data set. The pipeline monitors for changes, and then when there's new data, it trains a new model, evaluates it, and deploys it. So this just allows us to do this automatically. So for example, if this is similar to a DevOps pipeline, where you would have a commit, trigger a build of the code, and then obviously test the code and push it out. So the same thing can be said about an ML pipeline. Once the data set changes, we would train a new model from that data set and evaluate it and deploy it. So for example, this is Python code in the Kubeflow framework that defines a data set. And you can see here the input to the pipeline is training data and then evaluation data from Google Cloud, for example. So once this data changes, the pipeline runs. And then it trains a new model with this new data and evaluates it and deploys it. OK, so once we have a pre-trained model, like let's say we did it manually or with a pipeline, where do we store it? So we store it in a model registry. So this is the version, this is the source control or version control for models. All the models live there. So data scientists push new versions of models there and pull and then iterate on them. And ML engineers, when they want to promote a model to production, they usually take a model from the model registry and then push it out to production. So this is an example of a very popular open source model registry, MLflow. So we can see all of the models living happily here with all the versions and aliases, et cetera. OK, so the last feature I want to talk about is model serving or model as a service. So once we promote a model to production, we have two choices on how users can use it. The first choice is called embedding. So we take the pre-trained model and we put it inside an application, and then the application just uses it internally. The second choice, which is a bit more popular, is called model serving or model as a service. So we just give the MLOps platform our model binary, and it wraps it in an API and makes it accessible through HTTP, for example. So this is, for example, like when you query ChatGPT, it's model as a service. You use API, and you query their model. So this just saves us the time from writing a custom web application, and this just gives us proper API for serving the model. So an example for that is one of the platforms that we researched is Seldon Core. So this provides model serving and, or inference server or model as a service. These are all the same names. These are all different for the same thing. So you give this MLOps platform your model. The way that it serves it, it wraps it in a Docker container, then it deploys it through Kubernetes, and it wraps it with a standard API layer. So you can serve a lot of different model types, and for your users, it will look exactly the same from the API. So this is also very easy to do. You just write a Kubernetes configuration, and you can see the only thing we need to really specify here is where the pre-trained model is, and then it will wrap everything for us and provide APIs, and we're good to go. OK, so these are some MLOps features, and now let's see how to attack these features. So in our research, we chose to analyze 6 of the biggest open source MLOps platforms and see how to attack them when they're deployed in an organizational network. So all the attacks here that I'm going to show are not theoretical. We actually did them on these platforms, and they're also valid for a lot of other MLOps platforms. OK, so I want to make an important distinction here. So let's look at the CVE. It's sort of a nonsense CVE, and we'll understand why. So this was rightfully disputed, and it's about a Python module, a Python library that directly wraps the pickle module. And what the CVE says is if you unpickle untrusted data, then you can have arbitrary code execution. So that's like, yeah, of course, you don't say. Like obviously, this is something that's very well known. It's the known behavior and expected behavior. So everybody knows about that pretty much, and that was also the dispute reason. So if you go to Python documentation, there's a big red warning, don't unpickle untrusted data, it leads to code execution. So the point here that this isn't an implementation vulnerability, and it shouldn't get a CVE allocated, because there's nothing to fix. It's expected behavior. So this is an inherent vulnerability in the format that we're using. We're using pickle, and it's just an inherent vulnerability that if you pass untrusted data to it, you get arbitrary code execution. And we as users of Python have to know about this to stay safe. So the problem is that machine learning is a new field. So Python, OK, we're all seasoned, we know about it. But machine learning is a new field. So this raises the question, which of these inherent vulnerabilities are out there which we might not know about, right? So inherent vulnerabilities are scary because there's no CVEs, there's no software patches. Either we know about them or we don't. OK, so let's start with some inherent vulnerabilities in machine learning. So this is probably the most well-known one, but it's also the most dangerous one. And just models are code. So what does that mean? Some model formats actually support as a feature code execution on load. So you would think a model is just data, but no. When you load these specific model formats, they could be rigged to execute code. And by the way, if this is the first time you heard about this, welcome to the club. I was quite surprised as well to hear about this. And here you can see some model formats that support this feature and some that doesn't. But a lot of people think it's only for pickle-based models, but No, there's a lot of other machine learning model types that support this. So how does it look like? So here we have a decomposition of a Keras H5 model. And the exact details rely on the specific model format. But in Keras H5, there's base 64 data. It's called a lambda layer. It's a layer that runs code. And you can see it's just decoded bytes. And in the end, if we decompile these bytes, it's just a Python code object that sits inside the binary of the model. So the problem is that the user, they just wanted to load a model and use it, right? Query it, get predictions. And now they have code execution that they didn't expect. So we're going to see how this fact actually causes a lot of attacks later on. OK, so models can be code, but surely we can load untrusted data sets, right? It's just CSV data or Parquet data. It's simple data. It shouldn't cause code execution. So actually, depending on the format, this could also cause some trouble. So very very maybe well-known example is in the Hugging Face framework, in the Hugging Face public repository. So this is a public repository that you can upload both models and data sets, and it's like NPM and PyPI. You just upload things there, and everybody can consume it. So they have a data sets library, and it allows you to download and load a data set with just 2 lines of code. You call load data set, you give it the name of the remote repository of the data set, and it will just download it, load it. OK, so this is, for example, a CSV data set, and we have some textual data inside the data.tar. But what's this Python file doing here? So you probably guessed, but this API will also happily actually execute code for you. This is part of a feature of pre-training the data set. So if you don't know about this feature, and this is, for example, the full prototype of this function, there's an argument called trust remote code, and it's by default, it's true. So if you just call this function and give it an untrusted data set, you don't just get the data set, but you also get Python code running on your machine. So a machine learning or data engineer can easily not know about this functionality, right? They're just calling the API, and they're getting code execution. Another inherent vulnerability is in Jupyter Notebook or Jupyter Lab. So Jupyter is a really amazing tool. It's really loved by data scientists. And for those that are not familiar with it, it's a web application, and it allows you to write Python code blocks, both Python code blocks and documentation blocks, and then you can run each block separately and get the output from that block. So this is really amazing for interactive model testing, and I use it all the time when I'm working with machine learning models. So what you might know or not know about is inherently the output of each Python code block, and here's an example that outputs HTML. So it doesn't just show you text, it can output HTML and graphs and all sorts of things. And this HTML output can also have JavaScript in it, actually. What we learned is that this output is completely on sandbox. So this JavaScript code that may be there has full access to the DOM. It can manipulate the entire web application. So for example, because Jupyter is a web application that in the end it allows you running on sandbox Python code, if you control Jupyter, if you control the web application, then you can just run on sandbox code. You can run whatever Python code you want. So this is an example JavaScript payload that we wrote. And when you run it, it manipulates the DOM to add a new code cell and fill it with Python code and run that code. So when you run it, it looks like this. So you run the JavaScript, and then you get a new code cell at the bottom, and you can see we run calculator because we love running calculator. So this JavaScript code can actually cause Python code execution. So you might think, wait, is this really a problem? Like, OK, so just don't run untrusted JavaScript code in Jupyter, right? And then you won't get RCE. Maybe some of you are familiar with the situation that the browser will run untrusted JavaScript code. So yeah, of course, I'm talking about XSS. So for example, this is a CVE. This is a vulnerability that we discovered as part of this research, that when you run untrusted MLflow recipes, you get XSS. So what's an MLflow recipe? It's just a YAML file. I'm not going to deep dive into that because it doesn't matter for the security impact. But what you need to know, it's a format that's specific to MLflow. And usually when you load a YAML file, you don't get untrusted code execution. That's mainly the point. So what we discovered is that due to lack of sanitization, running a recipe can emit unfiltered HTML and, of course, JavaScript. So for example, a data scientist can get a malicious recipe from an untrusted source or from a man-in-the-middle attack. And then when you run that recipe, and you can see we injected some JavaScript into a specific part of the recipe, boom, you get XSS. And the problem, again, when this XSS is in the Jupyter environment, then this XSS is completely equivalent to remote code execution. So now we need to treat all XSS vulnerabilities in machine learning libraries as potential arbitrary code execution. So this just elevates XSS into a whole different level because the data scientist, they get XSS and they might be using Jupyter at that point. So this is another big problem. Okay, so now I want to talk a bit more about implementation issues and not inherent vulnerabilities. So these are vulnerabilities that are not inherent due to the use format, but they are classic issues that are more likely to plague MLOps platforms or just cause a severe impact on MLOps platforms. So at least in this case, it's not an inherent vulnerability. So when there is such an implementation vulnerability, it will get a CVE and it will get a fix. But spoiler alert, we're going to chain these inherent vulnerabilities and implementation vulnerabilities really nicely together to see full attack chains. So let's go over a few examples of implementation issues. So first of all, lack of authentication. So if you remember, I talked about ML pipelines. And as an attacker, if the MLOps platform supports a pipeline and I have enough permissions to edit the pipeline, then I can just run arbitrary code, because it's just, I can create a new pipeline with arbitrary Python code. So this is, I like to call it code execution as a feature. So some of these platforms require that the pipeline runs inside a Docker container, but some of them don't, and we'll see that. And you would think that with remote code execution as a feature, then probably the authentication on these platforms is really strong with role-based access control, right? Of course, as you would expect, the answer is no. So our research highlighted that many frameworks that support pipelines, they either don't support built-in authentication or they tell you, oh yeah, you should manage authentication yourself, like deploy a reverse authenticating proxy or something like that. So that means that simple deployments of these platforms is just remote code execution as a feature. There's no defense, and you can just define a new pipeline. So any user can just run arbitrary code. So some of these CVEs, most of these issues don't get a CVE, but some do. And this is an example of something that did in the Ray framework. So it's exactly the same issue. It's basically a framework that doesn't have authentication, and it allows you to submit arbitrary jobs, which is just running arbitrary Python. And I want you to look at the reason that the CVE was disputed. So I'll read it out as well. But Ray, as stated in the documentation, is not intended for use outside of a strictly controlled network environment. I mean, is this a reasonable dispute claim in 2024? Like, we didn't bother adding security to our daemon? I don't think it's a reasonable dispute claim. So what do you think? Do you think users actually read the documentation and didn't deploy this framework to production? Well, of course, they deployed it to production. So this was highlighted by great research by Oligo's security team. So this issue, the lack of authentication with pipelines, was already exploited on thousands of servers, and real malicious actors were running cryptojacking, crypto mining, whatever you want. And why wouldn't them? It's thousands of servers that are exposed to the internet. They don't have any authentication, and they support remote code execution as a feature. I would exploit it. So these are servers that people happily deployed to production without knowing the repercussions. So just to summarize this point, many open source MLOps platforms seem to lack authentication, and when it's coupled with the pipeline feature, it's just remote RC as a feature. Okay, so another vulnerability that has a very increased effectiveness against MLOps platforms is a container escape. So MLOps platforms use Docker containers in two scenarios. The first scenario is that when a pipeline is running, then some of the more robust MLOps platforms, they run the pipeline code inside a Docker. And then at least it's contained. It's not all of them, but at least some of them. So again, if an attacker can edit the pipeline, the attacker can run code inside the Docker in this case. And the second scenario is that a model that is served is loaded inside a Docker container and not just on the server itself. So here, whoever that can upload models can also run code because, again, models are code, and we'll see this. So in both of these scenarios, attackers with sufficient privileges can execute code inside the container. But breaking the container will allow the attacker to move laterally within the organization. So I want to focus on model serving as a breakout target because this endpoint is more likely to be exposed to attackers. It requires less privileges to serve a new model than to edit a pipeline. Okay, so in our research, we looked at two different platforms that provided model serving, so Kserve and Selden Core. So again, for an attacker, it's very easy to get code executed inside the serving container. The attacker just uploads a malicious model, and boom, we run code inside the serving container. Because again, models are code. Once the model is loaded, it just runs code. So in Kserve, the architecture here was actually good. So you can see that the model in the first pod, it doesn't have access to any other model that is currently served by Kserve. So with just code execution, we couldn't achieve lateral movement or access sensitive resources. But the problem is that, of course, a container escape exists, right? So if the model's payload would be laced with, let's say, local kernel local privilege escalation or any other container escape, then after the model runs, it could escape the container and just have lateral movement. So this is a good case, but a more problematic case, for example, Selden Core, which is also a model-serving MLOps platform and inference server. So here, at least they had a Docker container. That's good. So all the models are running inside a container. But here, it's not a good architecture because all of the models are running inside the same container. So why is this bad? So first, an attacker can still upload a malicious model, of course. The malicious model will appear in the serving container, and then the malicious model can hijack the container. But here, there's a problem. Because all of the other models are there as well, the attacker can do a few things. First of all, the attacker can poison one of these models. And because this is an inference server, now it means we control all the responses to all the queries that the models support. So for example, if a user asks, what's the best PyPI package for computer vision? Now the server will answer, yeah, check out the My Cool Remote Access Tool version 99. We control all the replies from the server from now on. The other thing that, because all of the models are in the same container, the attacker can now exfiltrate these models to his own cloud, just steal the models. And this is very problematic because, companies like OpenAI, if you steal ChatGPT 4, it's probably a few hundreds of millions of dollars, if not more. So you don't want this to happen. Okay, and the last implementation issue that I want to talk about is that sadly, I think we can expect a high number of security issues in upcoming years. So why is that? It's just because of the immaturity of these MLOps platforms. So MLOps platforms are still fresh. The oldest one we saw is about 5 years old, the open source ones at least. And AI experts are usually not security experts. They care about AI. They build the platform for AI first and not security first. So this is very evident from the number of CVEs we had in the last couple years, for example. So in MLflow, for example, we had 15 critical and 23 high CVEs. This is an abnormally high number of CVEs. And for example, the critical ones were also unauthenticated RCE, like think really bad stuff. And we can compare it to a robust project like Jenkins, a DevOps server. And in these past 2 years, they had 2 critical and 9 high CVEs, although Jenkins is much more highly scrutinized than MLflow. And I'm not picking on MLflow here, by the way. For example, again, the JFrog research team does a lot of external disclosures, and the biggest category where we did disclosures is definitely MLOps this year. It was 20 CVEs, and other categories, we found a lot less. Okay, cool. So now we have all of the pieces of the puzzle. We understood inherent vulnerabilities and implementation vulnerabilities. So let's see how we would take advantage of these vulnerabilities in the real world. Let's see a first attack chain where an attacker could infiltrate the entire organization from outside by using malicious models to infect clients. So this is relevant for model registries such as MLflow, weights and biases, and ZenML, for example, which we researched. So first of all, the attacker is going to upload a model to a public repository such as Hugging Face, a malicious model. And similar to NPM and PyPI malicious package attacks, we need to entice a data scientist inside the organization or anybody to load our model. So we'll have a cool description and it will look good, but in the end they will load our model. And by the way, it's very easy. It's 3 lines of code to load a model, to download and load a model from Hugging Face. And once these 3 lines of code run, boom, the attacker has a foothold inside the organization because we ran code on that data scientist. Okay, so now the data scientist consumed the model, and now the attacker is going to want to breach the model registry, which is inside the organization. So how will the attacker do that? So we saw a lot of them don't have any authentication. Even if they do have authentication, it makes a lot of sense that the data scientist will have stored credentials because the data scientist is working with this model registry. And lastly, we saw that there are a lot of CVEs, so the attacker can use a 0-day or 1-day in order to exploit the model registry. So now the model registry is infected, and the attacker took all of the models in the registry and added backdoor code to them. So now it means anybody that will load these models, boom, they get code execution. So as just regular organization workflow, of course, users and servers and CI/CD, they're going to load these models from the model registry. This is how it works. And again, to load a model from a registry, for example, these are 4 lines of code that will download the latest model from MLflow, for example. And as soon as they load the model, they don't have to query, they don't have to evaluate, they don't have to do anything. We ran code on everybody. And you can see how this is a worm that can keep propagating into different registries and users and infect the entire organization. Okay, so now let's flip the script and let's see how we can use malicious models not to infect clients, but now we're gonna infect servers. So these scenarios are relevant for MLOps platforms that have inference servers or support model as a model serving. So for example, Seldon Core and Kserve from our research. So let's say the attacker is already inside the organization or even on the cloud. So the attacker uploads a new model into the inference server. And like we've seen, it gets into a container. And this is the good case where there is a container. It might not even have a container. So models are code. So the model is running code, and we took over the container. And now we're going to lace the payload of the malicious model with a container escape. So this can either be a CVE or a platform-specific container escape like we just saw in the Kserve framework. And from there, the attacker can continue spreading inside the whole organization because they did a container escape and they're just living in the organization network. Okay, so a cool part is that we can summarize and see exactly which MLOps feature enables which attack. And also which post-exploitation technique they're vulnerable to, and what are the frameworks that are vulnerable to these attacks. So for example, if you're deploying a framework that allows for model serving, so now you know that anybody that can serve a model can actually just run code on that framework. So you would make sure that the environment is very hardened against container escape, for example. Okay, so let's have some fun. Let's exploit a 0-day. So our research team recently disclosed privilege escalation vulnerability in weights and biases, so I want to exploit it. For legal purposes, I have to clarify, it got a CVE ID a few days ago, of course, so it's not a 0-day anymore, there's a fix. But it's a very new 1-day, let's say. So we're going to simulate hijacking the weights and biases model registry using a remote privilege escalation. And then we're going to infect all of the models in that model registry, and then a data scientist is going to load one of these models and get infected as well. Okay, So I already have set up here the weights and biases locally. So I already have a project with a model and a data set. So this model, for example, is the MNIST model. It allows you to do optical character recognition. And this is what we're going to infect. So let's simulate a victim, which is let's simulate a victim, which is a data scientist. And the data scientist is going to run a common workload for a data scientist. And while I'm running it in the background, but while it's loading, I want to show you, the workload is evaluating, just taking the latest model from the model registry, and then evaluating it with a local data set. So it's going to load the latest model from weights and biases, and this is the scary part, because we're going to see how they get infected because of that. Then it's going to load a local data set. It's going to evaluate the new model, so it's running an evaluation and getting an accuracy score of this new model that we just loaded. And then we're going to log the score to weights and biases. OK, so we ran this common workload. It ended. We got an accuracy and loss score. But everything is fine. OK. So now, as an attacker, I want to hijack the model registry. I want to hijack weights and biases. So what I'm going to do, I'm going to run a privilege escalation attack. So this is, again, the 0-day that we discovered and disclosed. So this is a remote path traversal privilege, arbitrary file leak. So actually, it's a very simple attack, but very effective attack. So you can see I'm doing a curl request. And as part of the curl request, I'm going to a specific endpoint, but now I have path traversal. So I can leak any file I want. I can leak etc shadow because it runs as root. But what I'm going to leak all of the API keys from the weights and biases server. And this will give us the admin's API key, and then we can do whatever we want. So let's run that. So now it's going to open a browser just to grab my attacker cookie. It needs that for doing the attack. Good. Boom. OK, cool. So we leaked the API keys. Let's see what it looks like. OK, so this is the file that we actually leaked. So it's a binary file. It contains all sorts of things, but it also contains the API keys, so this part. So now, just after very simple parsing, we have the admin's API key. So the attack was successful. That's great. And now I'm going to run an infection. So I'm going to run it in the background. OK, so what does the infection do? So first of all, we're going to log in as admin, because we have the dumped admin API key. And that will allow us to do a few things. We're going to download the model that I just showed you. And we're going to lace it with a Lambda layer. So we're going to lace it with code execution. I love running calculator, so this is what my exploit is, but you can run anything you want here. And the cool thing is really I'm downloading an existing model, and I'm adding a layer on top of it, which will cause code execution, and nobody will be none the wiser. Like, the model still works fine, and everything works fine, but we just get code execution. And then we save the model, and we just upload it to weights and biases with the same name, but with a new version. OK, great. So it seems that the infection worked. I uploaded the infected model. So now I'm going to run the exact same script on the victim. And if you remember what this script does, it just loads the latest model, right? So it's going to download the model. Calc. So yeah. The model still works the same, everything is the same, but now we can hijack the entire organization because we hijack all of the models and run code with it. Thank you. OK, so this was a bit grim. We showed a lot of problems. Let's talk about some solutions. So first of all, our research team released an open source extension for Jupyter, which actually mitigates the XSS attacks that we saw. It does it by sandboxing the output elements. So now the output elements doesn't have access to the DOM, and you wouldn't be able to turn an XSS into full RCE. So we can install this right now in Jupyter Labs Extension Manager. It's called XSS Guard. We couldn't find a better name, but yeah. Something that changed actually after we submitted the talk and is very good. So Hugging Face actually realized that maybe running code by default is not that good. So they actually changed the flag of that API call that I showed, and now it's true by default. But to benefit from that, you would need to upgrade to the latest version of the datasets library, so please do that. But while this is fixed, I still urge you to not load untrusted datasets, because other libraries and other frameworks, they can use a dataset format that supports code execution as a feature, let's say pickle, for example. So at least now this is safe, but still something to be wary about. Okay, so what did we learn today, and what do you need to pay attention to when you're deploying an MLOps platform? So first of all, check for the 3 features that we mentioned. Check if your MLOps platform supports it. So ML pipelines, model serving, model registry. If your MLOps platform supports it, but you're not explicitly using it, so please disable it, because you saw the security holes that it causes. You should also check that the pipelines and the model serving is using a Docker container, because if not, it's very easy to run uncontained code. And also, like I showed, check that you actually have authentication in your MLOps platform, and if not, then you can deploy a reverse proxy or change a platform. Second, this is, again, a big one, that models are code. So if someone has the privileges to serve a new model in your inference server, they have code execution privileges. They can run whatever they want. You should prefer working with safe model formats. So like I showed, there are some other formats like safe tensors, PMML, message pack. They don't support code execution on load. So if you get your organization to use those, you're at least safe from that attack, unless there's a CVE. And brief anybody that loads ML models, tell them, hey, if you're loading an untrusted ML model, you're hacked, basically. And you can also use, there's open source and commercial tools that you can use to scan models and understand if they're malicious. So a good open source one is PickleScan. Unfortunately, it only works for pickle-based models, but it will tell you if the model is malicious. If you work with Jupyter Lab, then consider installing our plugin. It will just, there's not a lot of downsides. It just mitigates XSS attacks. And really, to conclude, I hope you understood today that your MLOps platform is a high-value target. It allows for massive infection. So don't let this happen to you. Talk to your CISO. Make sure your CISO understands that they need to start protecting their MLOps platform in the same level that they protect their domain controller. Thank you very much.